Okay, so I'm assuming it's something like this, like this question. And now this is asking us to use the midpoint rather than left RAM or a left area. So let me back up. So there's three ways we know how to use rectangles. We can use the left rectangle area approximation method, or we can use the right uh, rectangle area approximation, or we can use the midpoint. And then we can use trapezoids too, but that's another lesson. So I don't know. Let's do number 7. I like 1/x. It's a nice, easy function to graph. Nice axis. So here's what remember, 1/x looks something like the reciprocal function, right? Looks something like that. And from 1 to 5, so here's 1, here's 5. And first off, they're telling me to use 2 rectangles. So we're going to split that in half. Well, that's a distance of 4. So halfway would be 2. So won't that be at 3? Now they're telling us to do, well, let's talk about all 3 of them. If I want a left area rectangle approximation, here, let's get fancy. Let's see if I can get fancy and use this software's rectangle drawer. Let's see, it won't be perfect because my drawing's not perfect. So if I'm using a left LRAM, that's the left there, and that's the next left. Okay, see how that's going to overestimate the area because it's above it. And what you do is, if I'm using the left again, I'm not using the M and the mid-ram or midpoint like they're telling me to do. What I do is, okay, so area of a rectangle is length times width, and each of these rectangles are 2 wide, right? So 2 times, now what's the height? Well, this function, I'm looking for that point. Well, that's at 1. So remember, I'm using the left ram. So I'm going to go from the left end. So 1/1 is 1. So that has a height of 1. Now this is at 3. This next one's at 3. So that's 1/3. So I'll do 2 times 1 and 2 times 1/3. And notice I'm not even using the 5, right? Because I'm just care about the left end of the rectangle. So that gives me an area of, let's see, 2 plus 2/3 is 2 2 2/3, which let's write that as an improper fraction. I need more coffee this morning or something. That's 6. It's 8/3. Now, if I want to use a right ram approximation, here, let me see. I might have to, let me stop the video and I'll clean this up and do the right ram. Okay, for the right ram, right area approximation, here, let me get fancier and use different color. So I'm going to go from the right side. So notice this, well, let's see, part of it's my drawing. Well, I guess it's not. That shows that it under approximates. Okay, and that's just because this is concave down, right? And that's one reason why we know it's where it's over approximating, under approximating, is the concavity. So this one, let's see. So what we're going to do here is, let's see, this is, let me come back with a pen. This is at, see, again, it's 2 wide, so that's at 3. And I want to know how high it is here, because it's a right side, right? So that's 1/5. And I want to know how high it is there, which is 1/3. Notice I'm not even using it 1. And it's still 2 wide, so 2 times 1/3 plus 2 times 1/5. Well, that's going to be what? 2/3 plus 2/5. You gotta get common denominators. So let's see what's that. So 10/15 plus 6/15. That's 16/15. 16/15. So a little over 1, whereas this was a little over 2. Okay. Now if we do the MRAM, we're going to go with the middle. So I got to figure out what the middle is. And sometimes that's easier said than done. Let's see, I'll go to blue. So this is 3. So those are two wide, right? So isn't halfway at 2? Let's see. So what I do is I draw where that line hits the curve, and that's at 2, and I'll do the same thing here. So that's 2 wide, so that's at 4. And then here's my rectangles. Let's see here. I want to do rectangle, and you kind of get an eyeball when you draw them in. And I recommend you draw these, folks. It's a lot easier. I think it's easier if you do. And that should have drawn up a little higher here. Let me redo that one. Part of it's because of my lousy sketch. So now what you do is you got to figure out the height at those midpoints. So let's see, that's at 4, right? So 1 over 4 is that height, and 1 over 2 is that height, and they're still 2 wide. So 2 times 1/2 and 2 times 1/4 is 1 and 1/2, so that's 3/2. Okay, so a little bit just so for each of these, MRAM's kind of cool because it kind of overestimates and underestimates at the same time. So they kind of cancel each other out. You see, you've got this one's illustrated pretty well. So yeah, you get that part above the curve, and you get this part that's below the curve. Those kind of cancel each other out. Now, I'd get a better estimate if I use more rectangles. And that's where we go in, when we start talking about Riemann sums and the formula, doing a limit. I get ahead of myself though. So then what you do for 4 rectangles here, let's do, and since you know about MRAM and all that now, let's just jump right to what they want us to do is do 4 rectangles. So here. See, I got smart and I started copying it. So except I need my pen, I'm not so smart. Let's see. What did I do with my pen? Just a minute, folks. I lost my pen. I won't tell you how long that took me. Let's see. So I got to go. I'm going to do midpoints, but I got to split these up into 4 parts. So I know that here. Where is everything? So there's 4 parts, 4 equal parts. Now this is a distance of 4, so that's 2, that's 3, that's 4, and they're asking me to find midpoints. So I'm going to do those midpoints there. Notice I've got 4 midpoints, 4 rectangles. And then let me draw these in here. Let's see here. So there's one rectangle. There's another rectangle. Another rectangle. Another rectangle. Now each of those rectangles are 1 wide. And I just got to figure out the heights. Well, isn't this 1.5? All right, now I don't have my pen again. My hand's cramping. Just a minute here. I'm having a hard time. Okay, so those midpoints, let's see. So this is 3/2, right? 1.5. So we're going to do what's 1 over 3/2. This one is at 5/2, right? 2.5. So what's 1 over 5/2? And this is at, let's see, 3.5, which is, see, remember, I'm doing those midpoints. That's why I'm saying these, lots of drawing, but you get the idea, right? Actually, why don't I just come over here? So I know they're 1 wide. I know, y right 1. So 1 over 3/2 is 2/3. And plus 1 wide times 1 over 5/2 is 2/5. Plus 1 over, let's see, 3 and 1/2 is 7/2, right? So times 2 over 7. And then the last one will be, 4.5, which is 9/2. So 1 over 9/2 is give myself a little more room. 1 times 2 over 9. So that just means I'm going to add 2 over 3 plus 2 over 5 plus 2 over 7 plus 2 over 9. And then all times 1 doesn't matter, right? Let's see. Do you really want to watch me do this arithmetic? But that's what we want to do. What is the common denominator of all those? Maybe it's be worth doing. These are, well, let's see, not relatively prime because the 9. So what's 45 times 7 is going to be my common denominator, isn't it? 45 times 7, I'm getting 315. So these are all going to be over 315. So that divided by 3, I should be able to do in my head, but I'm not right this second. Let's see, 315 divided by 3. So I got to multiply the 2 times 105, so that's 210. Plus, and let's see, I got to multiply the 2 times 63, right? So that's 126. Plus the 7 gets multiplied by 9 and 5, which is 45. 7 times 45 is 315. No, I didn't do something right. Let's see, I'm missing. Yes, I'm missing the 9 and the 5. Oh, that doesn't sound right. That's not 1. Oh, let's see here. 7 times 5 times 9. Did I not multiply that right? It's 315. Just a minute. Let me figure out what I'm doing wrong here. It's 2 times 45. Oh my God, I don't believe I did that. See, I should have been writing it out. With more real estate, I would have done this. I'm trying to make that denominator be 315, so that gets multiplied by 45. So I got to multiply by 45 over 45. You probably realized what I was doing. Sorry about that. 90 plus, and then 2 times 35, right? Which is 70. So if we add all those numbers up, 210 plus 126 plus 90 plus 70 gives me 496. So for 4 rectangles using MRAM, I'm getting 496 over 315. So that's the estimate. And let's just see, what's the exact area? Let's see, what are we doing? I'm doing 1 over x. You'll learn how to do this shortly, so I won't spoil the surprise for you. If you've sat through this class already and this is your second time through. So I'm getting an exact area of 1.609. 1.609. And what is 496 divided by 315? 1.57. So see, it's starting to be a much closer approximation than where we're getting before. Now, if we went to an infinite number of rectangles, we'd get even a better guess. So, but that's what they're asking to do when they're asking to find the area under a curve between 2 values. But for now, we're just doing rectangles. And actually, that's all we ever do is use rectangles, but we come up with an easier way than calculating all the separate rectangle areas. Okay, hopefully this helps.